Hi friends, welcome back. Now it is time to see the synchronous sequential circuits in a bit more detail. Basically, there are two models defined for synchronous sequential circuits. One is called the Moore model and the other one is called Mealy model. In the Moore model, the output depends on current state only, has nothing to do with the input, whereas in Mealy model, the output depends both on current state as well as the inputs. So it only means when we are working with Moore model, the output depends on the state. That means we are in some state, and in that particular state, if inputs change, output won't change because the output changes only when state changes. For state to change, we require a clock. So till the next clock arrives, there won't be change in the state, and in this period, even if the input changes, the output will not vary. So that's the Moore model. Whereas in Mealy model, the output depends both on state as well as the input. That means in a current state, till next clock arrives, the machine will be in one state, and during that period, if input changes, output will definitely change. So these are the two models we have, and where such things can be used is the issue to look at. So a simple example would be, I can just put that in a terms of block diagram. This is our inputs, these are the states. Okay, these states are fed back with a delay. Then from the states, outputs are derived. So that's a Moore model. Whereas in Mealy model, so there are inputs and there is state. These states are fed back through a delay, and then to generate the output, the Moore model depends only on the states, whereas this depends on input also. So inputs are also given to this block, and current state as well as current input both will decide together what should be the output, and this is a Mealy model. Done. So what are the examples? The simpler example would be, say for Moore model, we can take a traffic light system as an example. Say we are talking about a traffic light system at a junction of four roads. So at each road there will be traffic indicators, signal indicators, which are made of three lights. red, orange, green. So if I just say this is 1, this is 2, this is 3, this is 4, then there will be red 1, orange 1, green 1, red 2, orange 2, green 2, red 3, orange 3, green 3, red 4, orange 4, green 4. How does this work? Is, say we started with the red one, we started with the traffic we wanted to leave at road 1, so it was red 1, then we initiate that traffic 1, get ready, that you will be allowed, and then said go. And while all these things are happening, R2 is there, R3 is there, R4 is there. When all three are happening, R2 is there, R3 is there, R4, that means other lanes are closed. Just a simpler version. Once this green activity is over, then we start with the second one. So first one we close it, then second one which was red turns into orange, then turns into green, and these times R3, R4 are still on. So saying that 3 and 4, 1, 3, 4 are in red. So no traffic from lane 1, lane 3, lane 4 are allowed. So lane 2 you start. So it gets into O2, then G2. Once this is done, then it comes back to R2. And once it is R2, then R3 becomes O3 and then G3. So during this time, first lane is off, second lane is off, fourth lane is off. So third lane is working. Then after some time, third lane also gets stopped. Then R4 becomes orange 4, then becomes green 4. So during this time, R1, R2, R3 are on. After this, fourth lane becomes red, and then this whole process gets back and first lane starts working. So here what is happening is all these activities are taken on some time basis. So first this lane is allowed, then this lane is allowed, then this lane is allowed, then this lane is allowed. So here some constant timings are maintained for each one, and then in this way the traffic is allowed. First lane 1, then lane 2, then lane 3, then lane 4, back 1 2 3 4, 1 2 3 4, and so on. So for allowing lane 1, which was R1 in the beginning, becomes red 1, then becomes green 1. I hope after green 1 it should get back to orange 1 and then red 1. Yeah, this should be the sequence. So red, orange, green, orange, red. So for every lane this should be the sequence. Now what is it? What inputs we have? Nothing other than clock. We don't have any input. Only thing is we know at appropriate time appropriate light should be turned on, other light should be turned off, and that's what we need to work with. So no inputs required, it just works on its own. But if you want to see the timings, then in this case what is happening is all the timings are constant, all the timings are constant. So for some time it is R1, for same time it is O1, for same time it is G1, then O1, then R1. So that way everything is working for fixed time. But what we require is for R1 it is till you come back, till it becomes O1. It should be R1. O1 is for small period. Then G1 is a bit longer period compared to O1. So the period of O1 should be less than G1. But G1 is very much less compared to R1, because when other three lanes are working, first lane should be off. Therefore, red will be off for very long period, orange will be on, red will be on for very long period, orange will be on for very small period, G will be on for moderate period. So that's little modifications we can do just by saying, if you fix up each one, then in place of saying just one R1, you continuously say four times R1, 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 one times O1, then two times G1. That what happens is, the time used for orange, time used for red, time used for green will be different. So time used for red is four times time for orange, and time for green is two times time for orange. So that way it becomes more realistic. But still not very much realistic, because whatever we are doing blindly. We are not following how much traffic is there on each lane. So if you can know what is the traffic in each lane, if you can know what is the traffic in each lane, then this green can be controlled according to traffic. If traffic is more in lane 1, make sure that green is on in lane 1 for very long time compared to other three greens. Same way, if lane 3 is having more traffic, then lane 3 green should be made on for longer period. Or sometimes it may so happen that lane 4 doesn't have any traffic. In that case, we can just neglect this. Why do you turn on orange, then green, then back orange, then again red? Don't turn on this at all. So we can directly jump from 3, it can go directly to 1. So now what are we doing is, we are looking at inputs. What is input we have? We are just trying to find out traffic in each one. And if you can control the output through the traffic, then yes, what is it? It is looking into input and where it is, and that appropriate output will be turned on or off depending on the traffic is there or not. And the duration of on depends on how much traffic is there, and so on. So such a model will be a mealy model. Many more examples to follow. So as on now, that's it for now. Take care, see you, bye.